Hello everyone, welcome to the next tutorial. In this tutorial, we are going to learn more about inductor. Okay, so what is inductor? So inductor is basically an electrical component that stores energy in form of magnetic field. Okay, so let's say an inductor with iron core, an iron core inductor is supplied with a alternating supply. So we have given an alternating supply to this particular inductor. Okay, so let's say A is the cross-sectional area of the inductor and L is the length, okay, length of the inductor. Okay, so according to Ohm's law in magnetostats, okay, so according to Ohm's law in magnetostats, we can say that MMF, magnetomotive force, is equal to phi into reluctance. Okay, so what is phi? Phi is basically your flux. Okay, so magnetic flux, phi is your magnetic flux. The value of MMF stands for your magnetomotive force. Okay, so the value of MMF will be equal to N into I. Okay, so what is I? I is basically the current, okay, that is flowing from this particular inductor. Okay, the value of the reluctance is similar to that of resistance, and reluctance is responsible for the opposition. So reluctance is responsible for the opposition to the flow of magnetic flux. Okay, the flow of phi or your magnetic flux. So the value of the reluctance is equal to 1 upon mu naught mu r L upon A. Okay, so what is mu naught? So mu naught stands for the permeability. Okay, permeability. So the value of the permeability of a free space is equal to 4 pi into 10 raised to power minus 7 henries per meter. Okay, mu r stands for the relative permeability. So it is basically a relative permeability of the core of the inductor. Okay, so of inductor core. So on substituting the value of reluctance and MMF in this particular equation, we are getting MMF, which is Ni, is equal to flux phi into reluctance 1 upon mu naught mu r L upon A. Also, the value of the flux is equal to L into I. Okay, so it means that Ni is equal to Li into 1 upon mu naught mu r L upon A. So on solving, so the value of the inductance will be equal to mu naught mu r N square A upon L. Okay, this is the value of the inductance which you need to remember. Okay, so we will use this expression to solve various kinds of numerical problems. Okay, so few important points which you need to remember about inductors are, let's say we have given a DC supply to this particular inductor. Okay, and I is the current flowing from it. So according to the formula, E is equal to L d upon dt of I. Okay, since a DC supply is connected across the inductor, it means that the rate of change of current with respect to time, so di by dt will be equal to your 0. Okay, so it means that E will be equal to 0 volts. It means that the voltage across this particular inductor will be equal to 0 volts. So inductor works as a short circuit whenever a DC supply is connected across it. DC is connected to it or across it. Okay, connected to it. So it means that inductor opposes sudden change in current. Okay, sudden change in current, because in order to have a change in the current, a sudden change, and infinite, so the voltage across the inductor should approach to infinite. So an infinite amount of voltage is required to have a sudden change in the value of the current. Okay, let's say this is your current and this is with respect to time. So the current remains constant because the di by dt in case of an inductor when it is connected to a DC supply is your 0. Okay, The next thing you need to remember is the value of the inductive reactance. The value of inductive reactance, or you can say XL, is given as omega into L, where omega is your angular frequency, and it has a value is equal to 2 pi f, where f is the frequency of the supply. Okay, so it means that the value of the XL will be equal to 2 pi f into L. Okay, ohms. Okay, so that's all for today, guys. I will see you in the next tutorial. Thank you.